video doesn't have any fancy sound, so I'll narrate a little bit. This is the monster that we're trying to control here on a honeybee. You can kind of see right here next to me a blurry image of the mite. This is the inside of one of our test colonies, and our device is completely covered by honeycomb there. It's the close-up of our device, the bees inside. And then here we can actually see a bee going through the detection system. And that's that red light bouncing off the bee's abdomen. That's what happens when we find Varroa mites. So here you can see the exoskeleton is busted open. And this is our current working prototype right there. Okay, so I'm Hailey Scofield. I'm co-founder of Combplex, and we are solving beekeeping's biggest problem. That problem, as previewed in our video, is a parasitic mite. It's about the size of a tick, except if our ticks were the size of dinner plates. It's this massive, international, invasive parasite that has been plaguing bees for the last 30 years in the United States. So Varroa mites are responsible for 50 to 80% of the annual colony losses that we experience across the US every year. These losses result in $1.2 billion in added costs and losses for US agriculture. Combplex has invented a sustainable, innovative solution for Varroa mites that targets the mites in the colony year-round, chemical-free. So how do we do that? First, when the honeybee is walking through a natural opening in the corner of the frame, we can look and see if she's carrying a mite. When we detect that a mite is present on the bee, we can target that mite and eliminate it. And we do that by launching a 1 millisecond pulse of a laser. That causes the exoskeleton of the mite to actually erupt and explode. The mite, of course, dies instantly, and the honeybee is left unharmed. That means that the colony has this low churn of constant mite elimination in the area of the colony where the mites reproduce and are concentrated. This allows the colony to be incredibly healthy compared to how we treat colonies today. So this is a global problem because every honeybee colony in the world has these parasites. Right now, we're working closely with partners in upstate New York to continue to validate the efficacy of our device in commercial and hobbyist beekeepers in the state. Right now, our plan is to sell this device for $199 to beekeepers in an upfront cost and have an annual recurring maintenance fee. This is a really conservative projection of where we'll be in 4 years if we continue to bootstrap. We're fifth-year PhD students, and so we're looking forward to graduating and working on Combplex full-time. So the way that we deal with Varroa mites today, because if you don't treat for Varroa mites, your colony will die. The way we do it today is first you have to understand how many mites are in my colony. And we actually do that with a very technical assay. You take one measuring cup, the same I use for baking, take 1 scoop of bees from within the colony, put it into a mason jar with 2 heaping tablespoons of powdered sugar, shake vigorously for 2 minutes, let sit for 1.5 minutes, separate sugar and bees, and you can count the number of mites that you have per approximately 300 bees in a colony. That is the gold standard that I publish in my research. It's insane. To treat the mites that we find, we actually waft vaporized acid into the colony. And most beekeepers don't even look to see if they have mites. It amounts to basically chemotherapy for a colony because our competitors here have chemicals that either harm the brood or can actually kill the queen of the colony, never mind the mites. So our solution is permanent. It doesn't harm the brood. It doesn't touch them at all. It doesn't hurt the queen because the queen doesn't have mites. It's year-round. It's permanent. Most importantly, it's safe for honey. We're not putting added chemicals into a bee colony when it's producing honey. So my co-founder and I, Nathan, we're both fifth-year PhD students. I've studied honeybee health for a decade, and Nathan studies complex systems in computational biology here at Cornell. We have bootstrapped $2,000 for $3,000 that we need for industrial engineering so that we can use a $4,000 grant that we've secured through the New York Farm Viability Institute. This is just for manufacturing costs and is our major validation study. But we need to make these devices bee and beekeeper proof, which is actually kind of difficult. So we're also interested in how honeybees and honeybee health reflects in the agricultural community. And we do that by looking at how the value of a bee colony is not just to the beekeeper, but according to the USDA, it's actually 100 times that value to the community. They're really important, and not just for food production. Our long-term goal is to actually use the data that we can collect from honeybee colonies so that when beekeepers and farmers make a deal for pollination, it reflects the actual ecological health of the landscape that they're working in. So with that, I'll take any questions. Oh, no questions. Never mind. Sorry. Thank you.
Thank you.